So, very good evening, everyone, and welcome to the NPTEL's 12th live interactive session on the course Engineering Metrology. So, the course instructor for this course are Professor J. Ram Kumar and Professor Amanding Singh Oberoi, and I am an additional TA Shubham Jaiswal. I am a research scholar in the Department of Material Science and Engineering at IIT Kanpur. So in this live interactive session, we will be going to solve some samples problem related to your weekly content, which will in turn will help you to solve your weekly assignment. So as this is the interactive session, I hope for the interaction. So before going to solve actually some problems, we will quickly recapitulate what we have covered in the last week content. So in the last week, we have started with the quality control. Quality control. So what is quality control? It is a procedure or a set of a procedure which are intended to ensure a quality of a manufactured product, so that it can adhere to the defined set of quality criteria that we have set. Okay. So quality control is the procedure or set of procedure which are intended to ensure that a manufactured product adheres to a defined set of quality criteria. Okay. So this we have seen about the quality control. Okay. Then after that we have seen the similar term, that is quality assurance. So what is quality assurance then? It is same as set. It is a set of a procedure which are intended to ensure that the product or a service which is under development should satisfy the defined set of quality criteria. So that is nothing but the quality assurance. So QA is defined as a set of procedures which are intended to ensure that a product or service that is under development. So we can simply say that the quality assurance is nothing but the before manufacturing. So it is before manufacturing. Okay. So after this, we have seen the what is statistical quality control. So statistical quality control is comprises of three things. First one is the descriptive statistics. Okay, so what is descriptive statistics? It is used to describe the quality characteristics and their relationship. So used to describe quality characteristics and relationship. Okay. So generally we use like the terms like mean, standard deviation, range, etc. Okay. So after that we have seen the statistical process control. So what is statistical process control? It is generally used to determine whether the our process is functioning properly or not. So in this we use different types of charts like X bar chart, R chart, P chart, and to see the different aspects of our production process. So whether the process is functioning properly or not. So and different types of charts are used to monitor different aspects of the production process. So this is first, second. Now the third aspect of our statistical quality control is acceptance sampling. Okay. So this we will discuss later. Okay. So after that we have seen the types of control charts. So types of control charts. So we have seen the two, like using these control charts, we can measure two different characteristics. One is the variable and second one is the attribute. So first one is our, I can write two different characteristics can be measured by control charts. Okay. The first one is our variable. When we talk about the variable, we consider continuous data. Okay, and if it is a continuous data, then we can use X bar chart or R chart. So if we consider the X bar chart, what we monitor is the process mean. Process mean. So the process mean is nothing but the measure of central tendency. So in another we can call it as shift in the central tendency. Okay. So in R bar chart, we monitor the process variability. Process variability. So it is the measure of, like what we are talking about is nothing but the dispersion of our process. Okay. So this is all about the X bar and R chart. Okay. So after this, we have seen the second characteristics, that is the attribute. When we talk about the attribute, it is for discrete data. Okay. So, Mr. Vijay, Mr. Bhuyan, can you confirm? Am I audible?
Yes, sir.
Okay. So in attribute, we use different.
Yes, sir.
Yeah. Thank you. So we use different charts like P chart. Okay. So when we talk about the P chart, so we use P chart for to represent the proportion or fraction of defective. Proportion or fraction of defective. Okay. So now second chart is C chart. Okay. So in C chart, what we talk about is nothing but the number of defects for a fixed sample size. And when we consider U chart, it is also similar to our C chart, but the difference is we consider defects per unit or the sample size is changing. Okay. And the last one is our NP chart. So NP chart, it is used to represent number of defectives in a sample of inspection unit. Number of defectives in a sample of inspection units. Okay. So at this point we have seen each and every chart in detail. So first we begin with the X bar chart. Okay. So in X bar chart, we control process mean or we monitor the process mean. So the central line and upper control limit and lower control limit are given by the following formulas. Where X bar is nothing but the mean. So upper control limit is nothing but so this is for X bar chart, okay, and X bar chart we use for variable data or for variable or continuous data. So similarly our R chart, or we call it as range chart, okay, range chart. So the the central line is given by R bar, and upper control limit and lower control limit are given by D4 into R bar and D3 into R bar. So we can get values of D4 and D3 from the table. So after this, we have seen the P charts. Okay. So P charts. So P charts we use for sample of proportion defective. P bar is nothing but defective, and the upper control limit and lower control limit are given by P bar plus Z sigma P, P bar minus Z sigma P, and standard deviation of proportion defective is given by P bar 1 minus P bar by N whole thing underneath. Okay. So after this point we have seen the next chart, that is C chart. Okay. So in C chart it is for number of defects or per unit defects in the fixed sample size n. So the center line is given by C bar, that is nothing but average number of defects. And the upper control limit, that is UCL, and lower control limit LCL is given by sigma bar plus Z under root of sigma C bar minus Z under root of C bar. Okay. So after this point, we have seen the two charts, that is U chart and NP chart. Okay. So let's write NP. U chart and NP chart. So when we talk about the V chart, so if we consider the C chart, okay, with C chart, sample size is 1 unit. Or that is, we can call it as fixed. Okay, but it is, in case of U chart, the sample size is greater than 1 unit. So that is the only difference between C chart and U chart. Okay, and the central line, upper control limit and lower control limit are given by the formulas. This is U bar plus 3 under root U bar n, U bar minus 3 under root U bar n. And NP chart, it's for the number of defective. So it is for number of defective. And the center line and upper control limit and lower control limit are given by formula P bar, where P bar is nothing but summation I equals to 1 to n di, that is defective Kn, or simply in another words, I equal to 1 to K percentage defective K. So, and the lower control limit is given by NP bar minus Z under root NP bar 1 minus P bar. Okay. So this is upper control limit and lower control limit, and upper control limit is given by same. Only the difference is in sign plus. Okay, so this is about the NP chart. Okay, so after this covering all these graphs, we went to see the term called process capability. So as you can see the word capability, so it talks about the capacity. Okay, so what is process capability? It is the ability of a production process to meet or exceed the preset specification. Whether our process is meeting or exceeding the specification that we have defined. Okay, so it's nothing but the ability of production process to meet or exceed preset specification. Okay, so we can define CP is nothing but specification with divided by preset width. So what is specification width is difference between upper specification limit and lower specification limit, and divided by preset width, that is plus 3 sigma and minus sigma. Total comes out to be 6 sigma. Okay, so what is the preset range? Actually, we are talking about the preset width. So it is the range beyond which it would not be accepted. So it is the set range beyond which it would not be accepted. Okay. So after this process capability, we saw a new term called the third most important parameter in statistical process control, that is acceptance sampling. So what is acceptance sampling? It is the term that is used to select the samples out of our given population to do the inspection and or to do the quality control. So we will select the samples from our given lot, and whether we will define whether the lot is need to be selected or rejected. Okay. So it is the term used to select the samples out of given population to do the inspection or to do quality control. So when does the acceptance sampling is most useful? When the number of items that is to be processed in a short time, like when there are many samples or many numbers of items are there and we need to process it fast. Okay, that time we can use the acceptance sampling. So most useful when a large number of items must be processed in a short time. So this is about the acceptance sampling. Okay, so then we have seen the some introduction to sampling plans. What are those? Single sampling plan. Like we will select a single sample and we will decide. Similarly, it is double sampling plan and sequential sampling plan. So at the end, we have seen the term called OC curve. Okay. So what is OC curve? It is operating characteristics curve, or some people call it as probability curve. So what does it tells? It tells the probability of acceptance versus the fraction defective. Also, we can define the terms like consumer rates, producer rates, average quality level, etc., or a lot percent defective. So it is the probability of acceptance versus fraction defective. And at the end, we have seen the CMM, that is coordinate measuring. Okay. So this was the quick recapitulation to the last week content that we have seen. So now we will move towards solving our problems. Okay. So the first problem is when the sample size is different, C chart is used. However, for the same sample size, we use the U chart. Is it true or false? Anyone? Mr. Bhuyan, Mr. Vijay, Mr. Rajesh?
False.
False. And why is it so?
When sample size is fixed, C chart is used.
Okay.
And
And we use chart for what purpose? Like fraction defective, number of defective, like okay. So thank you, Vijay, you are correct. Yeah. So first thing we use C chart and U chart for number of defects. Okay. So per unit, okay. But when we talk about the C chart, okay, so the sample size that we are using, it will be fixed, or we can say that per unit. But when we are considering the U chart, okay, when we considering the U chart, the sample size is changing, or different sample size we can use. Okay. So this statement is definitely the false. So now our second question: range chart monitors the dispersion or variability of the process. Is it true or false?
False.
False. Okay. So why is it so?
It's saying the range of maximum minus minimum.
Yeah. So what they have asked, range chart monitors the dispersion or variability of the process. So
Okay. It's true.
yeah.
True.
Yeah. You are right, Mr. Bhuyan. The range chart monitors the dispersion or variability of the process. So this chart is for variable. Okay. So in variable, we have two different charts. First one is the X bar and second one is our R chart.
Range chart.
Yeah. So when we consider the X bar chart, what we consider is nothing, what we monitor is nothing but the process mean. Process mean, yeah, average. Also is another word we can average. So this is mean is the measure of our central tendency. So in another word we can call it as shift in. Okay, whereas in R bar chart, okay, so we consider the range higher minus lower. Okay, so what is that? It is telling whatever will be the changes that is taking place in that range. Okay, so we are considering the how wide or how spread the data is. So what we are talking about is nothing but the dispersion. So we are process variability. So in another word, we are talking about dispersion of the process. So this statement is true. So now the third question is Control chart for attributes is used to measure or monitor the characteristics that have continuous, digital, discrete, analog values. Which one? Yeah, Mr. Bhuyan. Okay. So, when we discuss the what we have seen in the last lecture, last week content, in that we have seen the different types of control charts. Okay, like what are the two different characteristics that we can measure by control chart. So one is our variable and one is our attribute. So when we consider the variable, so we talk about the continuous data. Okay, and when we talk about the attributes, we talk about the discrete data. So here we talk about the discrete data. So digital and analog we are not talking about. So we can easily eliminate these two options like analog and digital. So the only two things remains here, continuous and discrete. So when it is variable, it is continuous. When it is attribute, it is discrete. So the next question is, what specific technique in manufacturing system is used to monitor variation? Design of SPC, continuous quality control, lean manufacturing. So Mr. Bhuyan is saying SPC.
SPC. Yes, statistical process control.
Okay, so is there any other opinion, Mr. Vijay, Mr. Rajesh?
SPC, sir.
So when we talk about the design of experiment, so we design experiment in such a way that we can study the factors affecting our process. Okay, so that is our design of experiment, like how the factors will be affecting our process. So how much experiment should I carry out? So that will be studied by design of experiment. Okay, so when we talk about the statistical process control, so what does it tell? Whether it just tells whether the process is functioning properly or not. That we determine through the statistical process control. So if we are determining whether the process is functioning properly or not, what does it imply? We are monitoring the process. So we are monitoring the variation. So the correct answer will be the one option will be the statistical process control. This will not be. So when we try to continuously improve our quality, okay, so that is our continuous quality control. So this cannot be the answer. And similarly, the lean manufacturing also. The only correct option is here is statistical process control. Okay. So the next question. The lot tolerance percent defective LTPD is a level of quality specified by consumer, producer, supplier, sampling plan. So what do you think? Mr. Bhuyan, Mr. Vijay, Mr. Rajesh, Mr. Virendra.
Yes, sir.
Any other opinion? So, before answering this question, let's go through the definition of lot tolerance percent defective (LTPD). So, what is this? It is the upper limit on the percentage of defects that a consumer is willing to accept. Okay, it is the upper permissible limit. Okay, like the customer or the consumer is telling that up to this limit I can accept the defect. Okay, up to this much percentage I can accept the defects. So after that I will not accept. So upper limit on the percentage of defects that a consumer is willing to accept. So here you can see the word consumer. So consumer is the one who is defining the limit. So what they have asked, the lot tolerance percent defective is a level of quality specified by. So it will be the consumer. Here consumer is defining that limit. So up to that limit, that will be the consumer risk, and after that limit, it will be our what it will be? Producer's risk, supplier's risk, or consumer risk. Suppose I am having this much defective, okay, like 0.1, 0.2, 0.2 up to 1. So if our customer is saying that up to this limit he can accept, so it's nothing but our consumer risk. And after this point, it will be producer risk. So consumer risk plus producer risk, that is alpha plus beta equal to 1. Yeah. So this is all about the lot percent defective. So next question is, an operating characteristics curve is a plot between consumer risk or producer risk, probability of acceptance and probability of rejection, percentage of defective and probability of acceptance, average outgoing quality and probability of acceptance. So let me draw the OC curve for you so that you can answer. Yeah. So what is this x-axis? This x-axis is in the quick recapitulation also I have written what is operating characteristics curve and between which two variables we draw.
Well, the acceptance fraction defect.
Yeah. Yes, Mr. Bayan, you are correct. So here, on x-axis we take percentage of defective, and on the y-axis we consider probability of acceptance. So maximum probability of acceptance is 1, that is 100%. So always remember that the operating characteristics curve, the probability of acceptance is 1. If it is more than, it cannot be always more than 1. Okay, so 1 is the highest limit, and for the percentage of defective, it is 100%. maximum defect that can be, it is 100%. Okay. So this was about our percentage of defective. Okay. So ideally we need a operating characteristic curve like this. Okay, but in actual we will get like this, somewhat like this. Okay, and so the correct answer one is the here. Okay, defective and probability of acceptance. So we can eliminate this and this. Okay, so next come the consumer risk and producer risk. So what they have asked, the plot between. Okay, so it is the plot between the percentage of defect and probability of acceptance. But we can't plot, but we can show the consumer risk and producer risk on the our OC curve. Okay. So what is consumer risk? The consumer risk means like up to that percentage of defective, the consumer is will accept the lot, and if it comes bad, so it will be the risk of consumer. Like suppose if I have 100 samples. Okay. So if I have 100 samples, if I pick one item and I see that okay, this one is defective, but I decided to keep it, keeping in mind that I will get a good product in that one. Okay. Okay. So like whether producer has put all the defective items are like that, but I will not care much about that. I will just pick, and depending on that I will select. Okay. So suppose I have selected that lot and they all came defective, or the most of came defective. So that will be risk bear by which one? It will be bear by our customer. So it is our customer risk. Suppose similar case 100 products are there, and the producer, what he are doing, he is producing some defective parts, like out of 120 are defective, and he kept in that defective part in our that lot. And suppose if a customer taken that the lot and it is come out to be defective, and he decided to reject that lot, so that one will be the producer risk. So what will the loss will be bear by whom? It will be bear by the producer. So that will be the producer risk. So this is all about our operating characteristics curve. Have you understood?
Yes, sir.
So the next question is, what precise movement does CMM have? Huh?
This is moving all XYZ coordinates.
Okay. And how many coordinates, like how many degree of freedom it will be having? Okay. This is our probe. Okay. So what is CMM stands for?
Coordinate measuring machine.
Coordinate we can use it to measure the dimension, or we can use it for reverse engineering. Also we can use it for inspection. So when we are talking about the measurement, okay, so we can measure the dimension in all the axes like X, Y and Z. Okay. So when we are talking about X, Y and Z, okay. So if we are measuring, then it should have the precise movement in all directions. So the correct option will be. And how many degree of freedom it will have? One is our X, Y and Z. So these are three plus and 3 minus. So the total degree of freedom comes out to be 6 degree of freedom. Okay, so remember these things. Okay. So now coming to the next question. In a double sampling plan, if the number of defects is between the two cutoff numbers A1 and A2, the recommendation is accept the lot, reject the lot, take another sample, none of this. So what will you do? Like if I have told you that use double sampling plan and I have given you the limit like A1 and A2 and I given you the sample and I ask you to give your conclusion whether to accept the lot, reject the lot or take another sample. What will you do? Okay. What do you think, Mr. Bhuyan, Mr. Vijay, Mr. Rajesh? So let's answer. So they are talking about the double sampling plan. Okay. So if I had taken one sample, okay, and it is the defects that is between A and 2. So what I will do, I will take another sample, and based on that, I will give my recommendation. Like if it is satisfy the condition, then I will accept. If it does not, then we will reject it. So they are asking about in a double sampling plan, if the numbers of defects is between two cutoff numbers A1 and A2, the recommendation is to take another sample. So we are taking another sample and depending on the defects in that sample, whether it is in the range that is A1 or A2, if it is, then we will accept, otherwise we will reject that lot. So next one is, which of the following chart is used to monitor the number of defects per unit? Assume N is fixed.
C chart.
It's C chart. When does we use U chart? It's for number of
More than one.
N is not fixed or N is changing. When does we use R chart? For
Variable data.
Continuous data and to monitor the process variability, or also we can call it as a dispersion of process. The next one is C chart. When does we use C chart? Same like a U chart, but the N is fixed. So the correct answer will be this one. That is C sharp. Yeah.
Hello, sir. Sir, in this but in this question they have not told the 10 is fixed and
That's why I
not
have
fixed.
mentioned you assume n is fixed, because that's why I have given you this thing like assume n is fixed. They have forgot to mention. Hello.
Okay, sir.
Okay. So if I
Okay.
the same question and if I say assume n is variable, so what will be the answer?
Your chart.
Yeah.
Huge.
Yeah. So that's why in the very beginning I have told you to assume n is fixed. Okay. So now the next question is X bar chart is used to monitor the changes in the mean of process, determine the number of defectives in a sample of inspection units, monitor the process variability, monitor the proportion of defective items.
Changes in mean process. Monitor the changes in mean process.
So if we consider the X bar chart, so this is my central line. Okay. That is X double bar. And suppose this is my upper control limit and this is my lower control limit. Okay. So if I am monitoring in case of X bar chart, what we monitor whether the values are shifting from my mean position or mean value. So like this. So here what we are checking the variation in the mean of the process. So to represent or to monitor the changes in the mean of process, we use the X bar chart. So the correct option will be this one, that is X bar. So if I need to determine the number of defectives in a sample of inspection unit, so which chart should I use for this condition? Determine the number of defectives in a sample of inspection units. What do you think, Mr. Rajesh, Mr. Vijay, Mr. Bhuyan?
NP number of defectives NP.
It's NP. And monitor the process variability.
Range variability.
R chart. X bar chart. And to monitor the proportion of defective items.
P
chart. Okay. So if sometimes you get confused, which chart should you use? Just look for these words: proportion of defective, process variability, or number of defectives in a sample. In question, they will mention this word. Okay, so from that also you can get an idea which chart to use. Okay, if you don't have the knowledge of in detail and just the basics of like for which one, easily you can use that chart and plot that chart.
Sir, how many types of charts are available, sir?
Like for attributes in your syllabus, we are talking about 4 charts, and for variable we are talking about 2 charts, like P chart, C chart, U chart, and NP chart. That is for attributes, and for variable that is 2 charts, X bar and R chart. So in total, there are 6 charts are there in your week content. So I have recapitulated, like I have I will provide you the short notes. Okay, if you go through these slides carefully after I upload it, so you can see that I have given the formulas for all 3 6 charts, and in which case which chart should we use, I also have given that one. Okay.
Sir, where you will upload, sir?
So it will be on your course platform. On the Swayam, you will get a problem solving session. If you click on that link, you will get the slides. Slides also you can get the video recordings of this session.
Video you can get, sir, but notes you can't get.
Yeah, you can get. Like if you click on problem solving session, one Excel sheet will be in front of you.
We need to develop
Okay.
Okay. In that you will get so in that you will get
Okay, sir.
So the next question is statistical process control is a part of statistical quality control. Is it true?
It's true.
Yeah, it's true. Because we are using statistical process control to control our quality or to ensure our quality so that it can added to a defined set of quality criteria. So yeah, it's true. Next question is which of the following graph is used to show whether the sample of data falls within the common or nominal range of variation? Bar graph, control chart, histogram, none of these. I will draw all these graph for you so that you can easily understand. Now this is bar, this is histogram, this is control or line graph. So now answer this question. Which of the following
chart.
So Vijay is saying control chart. So is there any other opinion?
Control chart is common nominal range.
Okay. So what they are saying that which of the following graph is used to show whether the sample of data falls within the common or nominal range of variation? Okay. So suppose we have set one variation range, like this is upper control limit and this is lower control limit, and how much data is failing within that range, or how much data is falling within that range. Okay. So only using this control chart only we can represent. So it will be the control chart. So if you talk about the frequency of occurrence, then we can plot using histogram. Okay. So next question is variables are continuous data, discrete data, stable data, none of these.
Continuous data.
Continuous. Yeah. When we talk about the variables, it is continuous data. So next question is which of the following is an attribute control chart?
P chart.
Yeah, simple one. In the beginning, we have seen the classification. This is variable. R bar chart is also variable. This is for attribute. So the correct option will be the P chart, and the P chart is used for proportion or fraction of effective. So next question is which of the following chart is used to represent the defects per unit? Assume N is variable. Rajesh, same question.
Okay.
P chart.
Yeah, Mr. Rajesh, this is the same question.
Yes, sir. Yes, sir.
Yeah. So here, for your understanding, I have mentioned you the assume N is variable. So if the n is variable, which chart we will use? It will be our U chart. So moving towards our last question. The range chart monitors the shift in the central tendency of the process. Is it true or false?
No, false. False.
So X bar chart we use for monitor
Mean.
mean. That is the measure of central tendency. In R bar chart, what we are dispersion of process. So that range chart monitors shift in the central tendency. This is totally wrong because the shift in central tendency is measured by or monitored by our X bar chart. So this will be our false. So this was our last question for this session. So if you have doubt in up to this 16 question, you can ask, or otherwise we can wind up our session here itself.
Yes, sir. Thank you.
Okay.